Hello everyone, this is Harsh and today I am going to start Python tutorial series. In this tutorial series, I will guide you step by step from basic to advanced concept. I will cover everything from variable and data type to loop and functions. So without wasting time, let's get started. So first, let's start with basics. What is Python? Python is a programming language that combines the feature of C and Java. It offers elegant style of developing programs like C. When programmers want to go for object-oriented, Python offers classes and objects like Java. Now I will show you one example for adding two numbers in Python. I am using Python 3.12. So let's see the program to add two numbers. So first I will assign 10 to A and 20 to B. Now let's print sum of these two variables. I will say sum equal to then A plus B. See, sum equal to 30. This code is easy to understand and develop, right? Hence, Python is gaining popularity among the programming world. Python is open source software, which means anybody can freely download it from www.python.org and use it to develop programs. Its source code can be accessed and modified as required in the project. Okay. We will see the feature of Python. There are various reasons why Python is gaining good popularity in the programming community. Some of the important features of Python are simple, easy to learn, it is open source, high level language, dynamically typed, platform independent, and also it supports procedure and object oriented programming. What do you mean by simple? If you see this program, here we have A equal to 10, B equal to 12. It's look like it is English and we are printing, so we are using print method. So print sum and then their sum, right? So it is very easy to understand. It is more clear and less stress on understanding the syntax of the language. Developing and understanding program will become very easy, right? What do you mean by easy to learn? You can see here program uses very simple structure. So developing program in Python become easy. Anyone can understand here like how to write the sum. We just have to get to value and we can add like mathematics, right? You know open source means we no need to pay anything for Python software. Python can be freely downloaded, right? We can use the source code to read, modify, and we can use in our programming. As you know, we have two type of programming language. One is low level and another is high level. A low level language uses machine code instruction to develop programs. These instructions directly interact with the CPU. Whatever instructions we are giving to the program, it will directly interact with CPU. Machine language and assembly language are called low level language, right? But the high level language uses English word to develop the program. These are very easy to learn and use, right? As you see this code, it is very easy to understand and write, right? So this is why it is a high level language. What do you mean by dynamically typed? If you see here, we have not declared A or B, we have directly assigned the value and we are not defining any type for this. If you assign any integer to the variable, that variable will be of type integer. Let's see if we assign, let's say str equal to some string. So now it is type of string, but we have not specified the type here. If we want to assign integer to str, that also we can do, right? There is no error. This is the meaning of saying that Python is dynamically typed language. What is meaning of platform independent? When a Python program is compiled using a Python compiler, it generates bytecode. Python's bytecode represents a fixed set of instructions that run on all the operating system and hardware. Using Python virtual machine, anybody can run these bytecode instructions on computer system. Hence, Python programs are not dependent on any specific operating system. We can use Python on almost all the operating system like Unix, Linux, Windows, all the operating systems. This makes Python an ideal programming language for any network or internet. As I told, Python support procedure and object oriented. In procedure oriented programming language like C, the program are built using function and procedure. But in object oriented language like Java, programs uses class and object. These are the most important feature of Pythons. Now we will see execution of Python program. Let's assume we write a Python program with name abc.py. Now abc is the program name and the .py is the extension of this file, right? Every program is typed with an extension name .py. Means if you are writing any Python program, then it should have .py as an extension. After writing the program, the next step is to compile the program using Python compiler. The compiler converts the Python program into another code which is called bytecode. Bytecode represents fixed set of instructions that represent all operation like arithmetic operation, comparison operation, memory related operation, etc., which run on any operating system and hardware. It means the byte instruction are system independent or platform independent. The size of each byte code instruction is 1 byte and they are called with the name bytecode. These bytecode instructions are contained in the file abc.pyc. Here the abc.pyc files represent a Python compiled file. Now next step is to run the program. If we directly give the bytecode to the computer, it can't execute them. Any computer can execute only binary code which comprises of ones and zeros. Since the binary code is understandable by the machine, it is also called machine code. It is therefore necessary to convert the byte code into machine code so that our computer can understand and execute our program. For this purpose, we should use Python virtual machine. What Python virtual machine does? It uses an interpreter which understands the byte code and convert it into machine code. Python virtual machine first understands the processor and operating system in our computer. Then it converts the byte code into machine code understandable to that processor and into the format understandable to that operating system. These machine code instructions are then executed by the processor and the result are displayed. What interpreter does? Interpreter translate our program source code line by line. That's why it is slow. The interpreter that is found inside the Python virtual machine run the Python program slowly. To rectify this problem in some flavor of Python, a compiler is added to the Python virtual machine. This compiler also converts the byte code into machine code but faster than the interpreter. This compiler is called JIT, that is just in time compiler. The advantage of JIT compiler is to improve speed of execution of Python program and thus improving the performance. We should remember that the JIT compiler is not available in all Python environments. For example, the standard Python software is called CPython, which is created using C language that does not include JIT compiler. But PyPI, which is created in Python language itself, uses JIT compiler in addition to an interpreter in the Python virtual machine. So this flavor of Python definitely offers faster execution of Python program than CPython. So here we will write a source code which is our Python program like abc.py. Now we will compile the program using Python compiler. It will generate bytecode and extension will be pyc. Now we will run this using Python virtual machine, so it will convert bytecode to machine code and then it will display the output to our computer. Normally when we compile the Python program, we can't see any pyc file produced by the Python compiler and the machine code generated by Python virtual machine. This is done internally in the memory and the output is finally visible. I will use Visual Studio Code for writing the Python program. So here I will create one Python program. I will say name sum.py. Now here we'll assign some value to A, some value to B, and then I will print sum equal to A plus B. Okay. Now let's save it. Go to terminal, then new terminal, and then here we will run our program using the Python command. Python space file name sum.py. See the output, sum equal to 20, right? Now we'll go to this path and we'll see if our .pyc file is there or not. You can see here we don't have any pyc file, right? But it should convert the py file into its bytecode equivalent file, which is pyc. Instead of doing this, it is displaying directly the output, right? What it mean? It means that all the steps in the sequence, like source code to bytecode to machine code, and then output are internally completed, and then the final result is displayed. Hence, after execution, we can't find any .pyc file in the directory. If we want to create .pyc file from the source code, we can use the command python and then -m and then py compile, okay, and then the file name sum.py. Here we are calling the Python compiler with -m option. The -m option represents module and the module name is py_compile. This module generates the pyc file for our .py file. So if we hit enter, then if we go to that folder, if we hit enter and then go to that folder, then we can see .pyc file is generated, right? So if you observe here, the pyc name is sum.cpython and that Python version. This is our program name, right? Then this is compiler which was created using the C, which is CPython. So now the question is, what is the use of .pyc file? We know that the pyc file contains bytecode. We get this file after the compilation is completed. First step is over. The next step is to interpret them using Python virtual machine, and this can be done by calling the Python compiler like python space that file name sum.cpython -312.pyc. What we are doing here, we are supplying .pyc file to the Python compiler. Now Python compiler will skip the first step where it has to convert the source code into bytecode, as already it sees the bytecode inside the pyc file. This file is executed directly by the PVM, which is Python virtual machine, to produce the output. Hence, the program takes less time to run and performance will be improved. This is the reason that the compilation of the project, the pyc file are distributed to the user who can directly run this file using Python virtual machine and view the output. What is the error here? No such file or directory. So let's copy this and now paste here. Can't open file this. Okay, this file is inside this folder, so we have to specify the path here. Okay. Now you can see the output. Now if you want to see the bytecode instructions that were created internally by the Python compiler before they are executed by the Python virtual machine, for this purpose we should specify the this module while using Python command. How to see the bytecode? We have to use Python, okay, Python command, and then the -m means model and then model name this, and then our file name, which is sum.py. Now we will see the bytecode. Let's see. This is the bytecode which is generated. See, these are the bytecodes. This is how we can see the bytecode of any program using this model. What is the role of Python virtual machine? The role of PVM is to convert the bytecode instruction into machine code, so that the computer can execute those machine code instructions and display the final output. To carry out this conversion, PVM is equipped with an interpreter. The interpreter converts the bytecode into machine code and sends that machine code to the computer processor for execution. Since interpreter is playing the main role, often the Python virtual machine is also called an interpreter. You understand, right? What is role of PVM, right? Main role is to convert bytecode instruction into machine code so that we can see the output whenever write the code and run the program. It will convert internally this code and we can see the output. How memory management is done in Python? As in another language, programmers should allocate and delocate the memory. But in Python, memory allocation and delocation are done during runtime automatically. The programmer need not allocate memory while creating the object or deallocate the memory when deleting the object. Python PVM will take care of such issue. In Python, everything is considered as an object. For example, string are objects, list are object, functions are object, even modules are also object. For every object, memory manager inside the PVM allocates memory required for object created in the Python program. All these objects are stored on separate memory called heap. This memory is allocated during runtime. The size of heap memory depends on RAM of our computer, and it can increase or decrease its size depending on the requirement of the program. As we know that actual memory for any program is allocated by the underlying operating system. On the top of operating system, a raw memory allocator observes whether enough memory is available to it for storing objects or not. On the top of the raw memory allocator, there are several object-specific allocators operate on the same heap. These memory allocators will implement different type of memory management policy depending on the type of the object. For example, an integer number should be stored in memory in one way and a string should be stored in different way. These issues are taken care of by object-specific memory allocator. To delete the object from memory, we have one model called garbage collector, which is useful to delete the object from memory which are not used in our program. The model that represents the garbage collector is named as GC. Garbage collector is the simplest way to maintain a count for each object regarding how many times that object is referenced or used. When an object is referenced twice, its reference count will be 2. When an object has some count, it is being used in another program and hence garbage collector will not remove it from memory. When an object is found with a reference count 0, garbage collector will understand that the object is not used by the program and hence it can be deleted from the memory. Hence the memory allocated for that object is delocated or freed by this garbage collector. Garbage collector can detect reference cycle. A reference cycle is a cycle of references pointing to the first object from the last object. For example, we have 3 objects A, B and C. The object A refers to the object B, whereas the object B holds a reference to the object C. Now, if the object C refers to the first object A, it will form a reference cycle. Even if the object A, B and C are no longer used in the program, still these objects contain 1 references to each one. Since the reference count for each object is 1, the garbage collector will not remove this object from memory. These objects stay in the memory even after the program execution completed. To get around this, garbage collector uses an algorithm for detecting reference cycle and removing object in cycle. Garbage collector classifies this object into 3 generations. The newly created objects are considered as generation O object. First time, when the garbage collector examines the object in memory and does not remove an object from memory due to the reason that the object is used by the program, then the object is replaced into next generation, which is called generation 1. When the garbage collector intends to delete the object for the second time and the object also survives for the second time, then it is placed into generation 2. So the older object belongs to generation 2. Garbage collector always tries to delete younger objects which are not referenced in program rather than the old object. Garbage collector run automatically. Python schedules garbage collector depending upon a number which is called threshold. This number represents the frequency of how many times the garbage collector removed or collected the objects. When the number of allocation minus the number of deallocation is greater than the threshold number, then the garbage collector will run automatically. We can know the threshold number by using the method get_threshold of GC module. When more and more objects are created, and if the system runs out of memory, then automatic garbage collector will not run. Instead, the Python program will throw the exception. When the programmer is sure that his program does not contain any reference cycle, then automatic garbage collector is the best suitable. In some cases where reference cycles are found in the program, it is better to run the garbage collector manually. For this purpose, we can use collect method of GC model. Manual garbage collection can be done in two ways. One is time based and another is event based. If the garbage collector is called in certain interval of time, it is called time based. If the garbage collector is called on the basis of an event, for example, when the user disconnected from the application, it is called event based garbage collection. However, running the garbage collector too frequently will slow down our program. Okay, now you understand memory management in Python. This is all for this video. You can find some cues related to this video in my community post. Try to answer it so that you will know how much you learned for this video. If you found this video helpful, let's share with your friends.